Have you ever designed a circuit and wanted to test it before actually building the PCB? Normally, you might use software like Spice, Proteus, or another circuit simulator. What what if I tell you that you can simulate electronic circuit directly in your browser without initially heavy software? In this video, we are going to take out a look at EWsim and online electronic simulator, and I will show you how to build and simulate a real circuit step by step. Let's get started. So I just open, and this is EWsim.io. So EWsim is an online electronic simulation platform. The main advantage is that everything runs directly in the browser. You can create a circuit, connect components, apply power, and observe the circuit behavior without physically building the circuit first. For electronics designers, this can be useful during the initial testing and learning stages. For example, instead of immediately connecting a 555 timer on a breadboard, we can first simulate the circuit and check what our calculation is right or wrong. So I just open the circuit simulation, okay, and it is the launch simulator. So once the simulator is open, you will see the main workspace is here, and we can place our electronics components them together, okay. And the interface is quite simple. So if you have previously used a circuit simulator, you should be able to understand easily. So I just go to, and I wanted to showcase a example, preloaded example. So this is a preloaded example I can show you. Okay. So this example is based on a DS1307 model. Okay. So let's start with the Arduino Uno. The Arduino Uno is the main controller of the project. It's performed two important jobs. First, it's communicate with the DS1307 IC, and second, it send the received information to the LCD. So you can think of the Arduino as the brain of this digital clock. Now let's look. DS1307 is a real-time clock, or we can call in not technical word, that is RTC. This job is to keep track of seconds, minutes, hours, day, months, and year. The important thing here is that the Arduino does not need to calculate time by itself. Instead, it simply asks the RTC what's the current date and time. DS1307 then send the information back to the Arduino. The communication between the Arduino and DS1307, that is RTC, use I2C communication, that is SDA and SCL. Okay. On the Arduino Uno, there are connected at A4 and A5. A4 is the SDA and SCL. So here we have A4 connected to SDA, A5 connected to SCL. Why we use 10 kilo ohm resistance? So you can see a 10 kilo ohm resistance connected to the 5 volt. This is a pull-up resistance. So this 10 kilo ohm resistance is connected to SQW out pin that can generate the square wave output at selectable frequency, typically, okay, 1 hertz, 4.096 kilohertz, 8.192 kilohertz. The 10 kilo ohm resistance is acting a pull-up resistance. So this is the basic functionalities of this uh, example. I just run this example, and this is RTC running, and it is showing 1603, 16 date, 16, and 3 is the 16 is the hours, 3 is the minutes and seconds, and 8 is the date of month and year. So it is the basic functionality of this project. Okay, I hope you understand what I am saying, and this circuit is very simple if you are making this. However, there is one important thing to remember: a simulation is not a replacement of real hardware. Real components have tolerance, noise, parasitic capacitance, power supply, problem, and many more other non-ideal effects. So I would use simulation as an early verification tool. First simulate the circuit, then build the hardware, and finally test the real circuit with actually instruments. Why I like this example? Because it's having the I2C, LCD, pull-up, digital communication, and much more things. So instead of just making a simple LED blinking, we can use EWsim to simulate something much closer to a real electronics project. So this is how we can simulate an Arduino-based digital clock using EWsim. We use an Arduino Uno DS1307 RTC and HD44780 LCD, and we look at the communication signal. If you are designing electronics, this type of simulation can be useful step before moving in the actual hardware. In the next video, we take much more interesting circuits. I hope you like this video. Please subscribe my YouTube channel. Thanks for watching.